Welcome to the deep dive. Today we're digging into AI agents. It's a term you're probably hearing everywhere right now.
Absolutely everywhere.
And let's be honest, it can feel a bit, well, confusing. Like everyone means something slightly different.
That's so true. There's definitely a lot of buzz. And, our goal today is really to cut through some of that noise, provide some clarity.
Yeah, exactly. We want you to walk away understanding what AI agents actually are, kind of how they work under the hood.
And why they might actually be, pretty relevant to you, maybe more than you think.
Right. So to get a handle on this, we've really studied this great video resource. It pulled together insights from various AI courses, research papers, and even some hands-on experience building these things.
Yeah, it was a really good synthesis.
Yeah.
Consider this your maybe fast track to getting a solid grasp on AI agents.
Okay, perfect. So maybe the best place to start is, what is an AI agent? Like fundamentally.
That's the key question.
Yeah.
And sometimes it helps to start with what it isn't.
Yeah.
So let's talk about something called one-shot prompting.
One-shot prompting. Okay.
Imagine asking an AI to write, say, a whole complex essay on a topic with just one single instruction.
Right. One big ask. Like, hey, AI, write me a 5-page analysis of the economic impact of renewable energy. Just like that.
Exactly. And the AI, well, it'll probably generate something that looks like an analysis. It might even hit some key points. But often, the result can be a bit vague. It might lack the depth or the specific angles you were hoping for.
Yeah, I can see that. It's like asking someone to build a house by just saying, build a house, you'll get something.
Precisely. Maybe not the house you actually wanted.
So if that one-shot approach isn't ideal, what's the alternative?
Well, that brings us to what's often called an agentic workflow. Instead of that one massive prompt,
Right.
you break the big task down into smaller, much more focused steps.
Okay. So back to the essay example.
Yeah, perfect example. An agentic workflow might involve the AI first creating a really detailed outline. Then maybe it does some targeted web searches for specific stats or arguments needed for section 2, let's say. Then it drafts section 1, then section 2, and then, crucially, it might review what it's written, maybe revise it based on some criteria, or even go back and refine the outline.
Ah, so it's more like a process, like how a human would actually write an essay, maybe, step by step.
Exactly. Breaking it down reduces the complexity. It lets the AI use different strengths or maybe even different tools at each stage.
So it's less linear and more circular, like think, research, write, check, maybe think again.
You nailed it. It's iterative. And this idea, it kind of leads us towards the concept of truly autonomous AI agents.
Okay, truly autonomous. That sounds advanced.
It is the ultimate goal, maybe. An AI that could, on its own, figure out all those necessary steps we just talked about.
Right.
Decide which tools it needs for each step, go through that whole improvement cycle by itself until it hits the target.
Wow, okay, that feels a bit like science fiction still. How close are we?
Yeah, we're definitely not quite there yet. For the most part, the focus right now is more on that second level we discussed, that agentic workflow.
Okay.
We're building systems that have agentic components. So individual parts within a bigger system that can make some decisions, break down some tasks, use some tools.
But not fully autonomous, not figuring out the whole strategy from scratch.
Exactly. They're not quite figuring out the entire problem-solving approach from zero. But, and this is important, this field is moving so incredibly fast.
Yeah, that's true.
Things that seem really far-fetched today could be, standard practice sooner than we expect.
Okay, so we're in this interesting middle ground, moving past simple prompts, building these more complex step-by-step agentic workflows. Now, the video we looked at, it highlighted 4 key agentic design patterns. There was a mnemonic, right?
There was. It's a good one. Red turtles paint murals.
Okay, red turtles paint murals. Let's break that down. What's the R?
The R stands for reflection.
Reflection. Okay, what does that mean for an AI?
It's basically the AI taking a step back and reviewing its own work. Carefully.
Huh, like proofreading.
Sort of, but potentially deeper.
Yeah.
Imagine you tell an AI to write some code. It generates the code, but it doesn't stop there.
Right.
You can then have it, or prompt it to, examine that code, check for correctness, obviously, but also for things like coding style, efficiency, potential bugs.
And it can critique itself.
Yes. And what's really powerful is it can often fix the errors it finds automatically. That self-correction piece is a huge leap.
Wow, yeah, like built-in quality control. That does sound like a big step up from just spitting out an answer.
It really is. And you can even take it further. Instead of you telling it to reflect, you can actually set up another AI agent whose main job is just to review and critique the first agent's output.
Ah, okay. So agents reviewing other agents, that hints at the multi-agent stuff you mentioned.
Exactly. It's a
Uh,
key concept for those more complex systems we'll get into.
Got it. So R is reflection. E isn't in the mnemonic, but the T in turtles must be next.
You got it. T is for tool use. This is where things get really interesting, I think.
Tool use, giving the AI tools.
Yeah. Giving AI access to external tools. It just dramatically expands what it can do. It's not just thinking, it's doing. It transforms the AI from just, an information source into an active problem solver.
Okay, what kinds of tools are we talking about? Give me some examples.
Think about asking an AI, what's the best rated coffee maker right now?
Okay.
If it only has its training data, that info might be outdated. But if it has a web search tool,
Ah, it can go look it up.
exactly, you can actively search for recent reviews, maybe compare a few sites, synthesize that info, and give you a much better current recommendation.
That makes total sense. Access to real-time information. What other tools?
Another really powerful one is code execution.
Letting the AI run code.
Yeah. So it can actually build things, like
Uh,
maybe generate the basic HTML for a simple website, or it can perform calculations. Remember that example, investing $100 at 7% compound interest for 12 years?
Right.
An AI with a code execution tool, like a Python interpreter, can calculate that future value precisely. It's not guessing. It's computing.
Wow. Okay, so it's not just retrieving info, it's actually performing actions, generating real results.
Exactly. And the possibilities are huge. We're seeing tools for image analysis like object detection, tools to generate web pages, even tools that let AI access your email or calendar to help you schedule things
The list is probably growing all the time.
constantly.
Okay, so red turtles. R for reflection, T for tool use. What's P in paint?
P is for planning and reasoning.
Planning and reasoning. So the AI figuring out how to do something.
Precisely. It's about the AI looking at the task you gave it and determining the sequence of steps needed to achieve it. And, importantly, figuring out which tools it might need along the way.
So it's not just following steps you give it, it can actually create the plan itself. That sounds like real intelligence.
It really does. Consider that example of generating an image.
Yeah.
You give it a picture of a boy reading a book, and you say, create an image of a girl reading, but in the exact same pose as the boy.
Okay, tricky task.
Right. To do that, the AI needs a plan. It might first use, say, a pose detection model. That's a tool to analyze the boy's pose from the input image.
Got it. Understand the pose.
Then, it uses maybe an image generation model, another tool to create the new image of the girl,
Yeah.
specifically instructing it to use the pose data it just extracted.
Uh-huh.
It might even then use another model, like an image-to-text tool, to describe the new image it just made. And then maybe another one, text-to-speech, to tell you what it created in audio.
Whoa. That's quite a chain. Pose detection, image generation, description, speech, all orchestrated by the AI's plan.
Exactly. It reasoned out the steps and selected the right tools for each step. That's planning and reasoning.
Impressive. Okay, last one. Red turtles paint.
Uh-huh.
In murals. That must be the multi-agent stuff.
You got it. Multi-agent systems. This is basically using multiple AI agents, often designed with different roles or specialties, to work together on a project.
Like a team.
Exactly like a human team. Think about a big project, you usually have specialists, right? A writer, an editor, maybe your researcher, a designer.
Sure. You don't usually have one person do absolutely everything.
Right. And research suggests the same principle often holds true for AI. Having different agents, each focused on a specific part of the problem, can lead to a better overall result than trying to make one single super agent handle everything.
That makes intuitive sense. Different models, or maybe the same model prompted differently, could be better at certain subtasks.
Precisely. One might be great at creative writing, another better at factual verification, another skilled at analyzing data.
So these four patterns, reflection, tool use, planning and reasoning, and multi-agent systems, these are like the core ingredients for building these more capable AI agent setups.
They really are the fundamental building blocks. And that last one, multi-agent systems, that's an area seeing a ton of development right now. The video actually pointed to a specific course on it, from Crew AI and Deep Learning AI, as being a really great resource if you want to go deeper.
Good to know. So let's dig into these multi-agent architectures then. If we're building a team of AIs, how does that work? What are the basic parts?
Okay, so the fundamental unit is still the single AI agent. And there's another helpful mnemonic for its core components. Tired alpacas make tea.
Okay, tired alpacas make tea. I'm sensing a theme here. What do these stand for?
Right, so T is for the task, the specific goal or objective for that agent.
Got it.
A is for the answer, the desired output. What should the agent produce?
Okay.
It's for the model, the underlying AI model powering it. Could be, Anthropic's Claude, OpenAI's GPT-4, whatever. This is the engine.
Right, you can often swap these out.
Exactly. And the final T is for tools, the resources the agent can access. Web search, databases, APIs, code execution, etc.
Task, answer, model, tools. Tired alpacas make tea. Okay, that defines a single agent. Can you give a quick example?
Sure. Let's imagine a travel planner agent. It's task, plan a 3-day budget trip to Tokyo.
Okay.
The answer it needs to provide, a detailed itinerary with flights, hotels, activities, cost estimates. The model might be, say, Anthropic Claude 3 Opus,
Right.
and its tools could be access to Google Maps, Skyscanner for flights, maybe Booking.com for hotels, perhaps even, if you allow it, your credit card info to make reservations.
Okay, that makes the single agent crystal clear. Now, how do we get to multi-agent systems from there? What's the simplest setup?
The simplest is basically just having 2 or more of these agents working together towards a common goal. Like our earlier example, a writer agent and an editor agent collaborating on a blog post.
So they share the overall goal, publish the article, but have different roles.
Exactly. The writer's task is drafting, the editor's task is reviewing and refining. They both contribute to the final answer, the polished article.
Can they have their own specific tasks too, or
Yeah.
use different tools?
Absolutely.
Yeah.
It can get quite sophisticated. Maybe the writer agent has access to a research database tool, but the editor agent doesn't need it. Or maybe a specific tool, like publish to website, is only accessible by the final agent in a sequence.
Okay, so even with just 2 agents, there are different ways they can interact. The video mentions several specific architectural patterns for these multi-agent teams, right?
It did. There are a few common ways to structure these interactions. One of the most basic is the sequential pattern.
Sequential, like an assembly line.
Exactly like an assembly line.
Right.
The output of agent 1 becomes the input for agent 2, whose output goes to agent 3, and so on. Think about processing a scanned document with AI.
Okay.
Agent 1 might just extract the raw text from the image.
Uh-huh.
Agent 2 takes that text and summarizes it. Agent 3 reads the summary and pulls out key action items. Agent 4 takes those action items and saves them neatly in a database or task list.
Got it. Step-by-step, linear flow. Each agent does its specific job in order, with another pattern.
Then you have the hierarchical pattern. Think manager and employees.
Okay, a hierarchy.
You have a central manager or leader agent. It oversees and delegates tasks to several subagents.
Yes.
These subagents do their specific work, maybe research analysis, drafting parts of a report, and then report their findings back up to the manager agent.
And the manager pulls it all together.
Exactly. The manager agent compiles the information, maybe synthesizes it, makes a final decision, or produces the final output, like creating a complex business report.
How so?
The manager agent could assign Agent A to analyze market trends, Agent B to gauge customer sentiment from reviews, Agent C to check internal sales metrics. They all report back, and the manager agent integrates it into one cohesive report, maybe even passing it to a final decision-making agent.
Okay, so top-down, delegation, and then consolidation. Makes sense. What else?
So you can combine these. That leads to hybrid systems.
Hybrid, mixing sequential and hierarchical.
Yep. You might have a top-level manager agent delegating tasks, hierarchical.
Right.
But the subagents might work in a specific sequence, sequential, to complete their part. Or there might be feedback loops going back and forth.
That sounds complicated. Where would you see that?
A classic example is an autonomous vehicle. Think self-driving car.
Okay.
There might be a high-level agent planning the overall route, but it delegates tasks to multiple subagents. One processing sensor data, one managing steering and acceleration, one constantly scanning for obstacles, another monitoring road conditions.
And they're all talking to each other, constantly feeding information back up and sideways.
Exactly. Continuous feedback loops are crucial there because the environment is changing all the time. It's a very dynamic hybrid system.
Wow. Okay, what other structures?
There are also parallel agent systems. Here, you have multiple agents working on different parts of a task at the same time, independently.
To speed things up.
Primarily, yes. Imagine analyzing a massive data set. You can split the data into chunks and assign a different agent to analyze each chunk concurrently. Then at the end, you just merge all their results.
It's like dividing the workload to finish faster.
Got it.
And then there are asynchronous multi-agent systems.
Asynchronous, meaning they don't have to work in lockstep.
Exactly. Agents execute their tasks independently, maybe at different times or intervals, without necessarily waiting for others. This is really useful when you're dealing with unpredictable situations.
Like what?
Think about AI for cybersecurity threat detection. You might have one agent constantly monitoring network traffic for weird patterns.
Uh-huh.
Another agent might be independently scanning systems for known vulnerabilities on its own schedule. A third might be randomly probing parts of the network looking for weaknesses. They're all working asynchronously.
And if one finds something suspicious,
It flags it immediately, maybe triggering other agents or human alerts without waiting for the others to finish their current cycle. It allows for more continuous reactive monitoring. Okay, that makes sense for things that need constant vigilance.
precisely. And finally, the video just touched on this, but you can even link entire multi-agent systems together into bigger flows.
Whoa, systems of systems?
Yeah, it allows for incredibly complex processing, but as you can imagine, it also gets much harder to manage. The potential for unexpected interactions, maybe even chaos, increases, a bit like how human companies get more complex as they grow and add departments.
Yeah, managing all those AI interactions sounds like a job in itself. Now, this all sounds quite technical. Building these hierarchical or asynchronous systems, is this only for hardcore coders?
Ah, well, this is where it gets really exciting for more people, because the answer is increasingly no.
Really?
Yeah. The video we watched really emphasized this point. You can actually build functional multi-agent AI workflows without writing code, using visual tools.
No code AI agents, seriously.
Seriously. They specifically mentioned a tool called N8N and highlighted a tutorial by someone named David Andre showing how to do it.
Okay, that lowers the barrier to entry significantly. Tell me more. What did they show?
They walked through a really practical example. A simple AI assistant built using Telegram, which they called InkyBot.
InkyBot. Okay, what does it do?
It's designed to help you prioritize your day. You can chat with it in Telegram, ask it about your schedule, and it can access your Google Calendar and even create new calendar events for you.
That sounds genuinely useful, and it was built without code. How?
The whole workflow was designed visually in NA10. It starts with a trigger. You send a message, text, or voice to the bot in Telegram.
Mm-hmm.
If it's a voice message, the first step in the workflow sends it to OpenAI to get transcribed into text.
Okay, so voice becomes text.
Then that text, whether you typed it or it was transcribed, becomes the input for the main AI agent node within NA10.
Got it. So how is that single agent set up in the no-code tool, using our framework, Tired Alpacas?
Exactly. So for InkyBot,
Answer the user's questions about their day, figure out priorities.
a prioritized to-do list maybe, and confirmation of any scheduled calendar events.
In their example, they used OpenAI's GPT-4o mini model. But the cool thing is N8N lets you easily swap in other models too, like Claude or open source ones.
Right, flexibility and the tools.
The critical tools for InkyBot were one tool to get events from Google Calendar and another tool to create new events in Google Calendar.
So even that single agent, just visually connected to a couple of tools, can understand your request, check your calendar, and add things to it, all without code.
Precisely. It shows that even relatively simple setups, built visually, can produce pretty cool and useful results.
That's amazing.
And you can imagine easily adding more agents or more tools to InkyBot in that same visual way. Maybe an agent to check your email for urgent tasks or one to summarize meeting notes. The potential is huge, and it really democratizes building these kinds of agent systems.
Yeah, it really opens the door for non-programmers to experiment and build practical AI solutions.
That's
Doesn't
fantastic.
it? Okay, so looking ahead, the video wrapped up with some thoughts on the future and the opportunities here. What was the big takeaway?
There was one key insight they really hammered home, something that apparently came from a Y Combinator video. And it's a really powerful idea.
Okay, lay it on me.
The core idea is this. For pretty much every major SaaS company, software as a service company that exists today.
Right, like Salesforce, Adobe, Shopify.
Exactly. For almost every one of those, there will likely be a corresponding AI agent company in the future.
Whoa. Okay, unpack that. An AI agent version of every sauce.
Sort of. Think about what those SaaS companies do. They provide software tools to help businesses or individuals accomplish specific tasks, managing customer relationships, creating add-ons, running e-commerce sites.
Uh-huh.
The prediction is that the way we interact with those functions will change. Instead of logging into complex software interfaces and clicking around,
Yeah.
we'll increasingly interact with intelligent AI agents that understand the domain sales, marketing, finance, whatever, and can perform those tasks for us, maybe more proactively based on conversation or high-level goals.
So instead of me manually updating Salesforce after a sales call, I might just tell my sales AI agent, hey, Log the call with Acme Corp, schedule a follow-up for Tuesday, and update their potential deal value.
That's exactly the kind of shift they're envisioning. The agent handles the underlying software interaction.
That's a fundamental change in how we use software.
It is, and the implication is that a whole new generation of major companies' vertical AI unicorns could emerge, essentially becoming the AI agent layer on top of or replacing the current sauce unicorns in each industry.
Wow. So if you're thinking about building something in AI,
A useful framework is to look at successful SaaS companies today and ask, what would the intelligent AI agent version of this look like? How could an agent transform how users get this core value?
that's definitely a powerful way to think about opportunities, a really thought-provoking perspective on where this might be heading.
It really is. It pushes us to think beyond just chatbots and image generators and towards agents deeply integrated into, well, almost everything we do digitally.
Well, this has been incredibly illuminating, a real deep dive into AI agents. We started by getting clear on the definition, right? Moving beyond simple prompting to these agentic workflows.
Yeah, and we covered those four key design patterns: reflection, tool use, planning and reasoning, and multi-agent systems red turtles paint murals.
Right. And then we looked at how you actually structure those multi-agent teams, sequential, hierarchical, hybrid, parallel, asynchronous, using the tired alpacas framework for the individual agents.
And importantly, we saw that building these isn't just for coders anymore, thanks to no-code tools like N8N, making it much more accessible.
Absolutely. And finishing with that really striking idea, the potential for an AI agent counterpart to almost every SaaS company, that's huge.
It definitely feels like a field with immense potential. Even though it's still pretty early days, the pace of change is just staggering.
It really is. Feels like we're genuinely on the cusp of a big shift. So maybe the final thought to leave everyone with is, given how fast this is moving, how these agents are becoming more capable and easier to build, how might they start to fundamentally reshape the everyday tools and services you rely on? Something to mull over.
Definitely something to think about.
Thanks for joining us for this deep dive.